Hello, welcome back. And in continuation, we are starting with next theory, which is Laplace Nebular Hypothesis. Now, that Immanuel Kant hypothesis was basically based on some sort of assumption. Assumption are also same here. Have some sort of variation that Immanuel Kant's theory. There was a assumption of cold nebula, cold cloud. Here we have an assumption of hot nebula or hot cloud, I would. And then most of the process is similar. However, there are some sort of minute differences are there. So basically this theory was actually based on that previous theory of Immanuel Kant. So this particular theory was actually given by this Laplace. So that's how he tried to explain it more logically, and this is the further refinement of Kant's hypothesis. Kant's hypothesis, or the Kant's idea which was there, this was further refined this particular in this Laplace Nebular hypothesis. As per this particular hypothesis, or let's say Laplace Nebula, what we can say that there was an existence. First of all, the assumption is what, that there was a existence of hot rotating gaseous nebula. In Immanuel Kant hypothesis, again I am telling you, I hope you remember, it was a cold cloud, cold nebula. It was actually the Laplace which termed that gaseous cloud in terms of nebula, that later attached or that later add to that Immanuel Kant's theory. Technically, the Immanuel Kant theory was actually known as gaseous theory, or let's say gaseous hypothesis of, technically I am saying. And technically, if you see the nebular hypothesis, that is associated with Laplace. However, this further led to the addition in the Immanuel Kant's theory. So here in the Laplace theory, there was a hot rotating cloud which was taken as a reference, and this is basically assumption theory. Nebula was actually incandescent, means this nebula was already emitting light. This nebula, which was actually hot, it was already bright. Unlike Immanuel Kant's theory, where we have a first proto-Sun and then the sun was there, here we have what? We have incandescent. Here I am not saying about the sun. Okay, don't confuse. Here we have what? Like nebula, and this nebula was already incandescent. Means it was incandescent, it was actually spreading light, it was actually bright, not because of the fusion, it is primarily because of the intense heat which was actually produced because of the gravity of that particular nebula, because of the gravity or because of the gravitational influence on those particles. They started to contract, and when they started to contract, temperature was increased, and as a result of that temperature, we have what? Incandescent condition, means bright condition. Light was already emitting from that particular. This is the first difference between the Kant theory and Laplace theory. So it's because of the self-gravity again, because of the self-gravity, because this nebula which was actually bright, and as this nebula was actually being bright, was contracted. As it was bright, it contracted. It was contracted because of the gravity. When it started to contract as a result of gravity, temperature was further increased in the center, and when the temperature was further increased, rotation was started. As a result of increase in temperature, rotation was started, and rotation becomes what? Faster. So as you know, in the previous story we got to know about the contraction. So when there is a contraction, because of the contraction, the particles will move towards each other, they will become close. As a result of that, gravity will intensify, temperature will increase, density will increase. In order to have an angular momentum, what will happen? That this irregularly spread dust or irregularly spread gas will going to be take a form of disc shape, and as it further denses it started to rotate. So that's how the contraction actually leads to temperature increase, and contraction actually leads to the rotation, and gradually these rotation becomes what? Faster, as the gravity was intensified, as these dust particles were accreted towards each other. As a result of this, what happened? Rotation becomes more and more faster, density increases. So due to the rotation, obviously I hope you are aware that when there is a rotation, due to the rotation, what would happen? To the rotation, the centrifugal force will be produced. So this rotation gave rise to the centrifugal force, and centrifugal force oppositely being balanced by the gravity. This is what the classical law of physics we can say. So centrifugal force is actually balanced by the gravity. Centrifugal force and gravitational pull were in actually equilibrium, but because of the further contraction, because of the continuous contraction, what happened? The density further increased, and as a result of increase in density, the centrifugal force actually outmark the gravitational pull, and as a result of centrifugal force which is actually more than the gravitational pull, as a result of this, what happened? There was an instability at the nebula's outer edges. So these outer edges of nebulas, they have some sort of what? Instability. It's obviously because of the more centrifugal force. It's because of the more centrifugal force. Now they have an affinity to move away from that nebula, especially the outer parts. And this, in this particular condition, when this rotation was keep on there, so this nebula shed its outer layer as concentric rings. Now this nebula is actually resulted into these concentric rings. It actually rips apart because of the more centrifugal force. The matter which was here, that started to detached from this particular part of, especially the outer part, and it keep on detaching. It keep on what? You can say remaining out from that nebula, and this process we are referring as what? Concentric rings of gas were there around the central core. So this was the what? The idea of Laplace, which was given in order to, or in order to justify theory, or in order to improvise the Immanuel Kant's theory. Now with each successive contraction, the contraction was further, and contraction was actually increased at the central part. As the contraction was actually increased at the central part, the centrifugal force become more intense. As it becomes more intense, the outer part of nebula becomes more unstable. As they becomes more unstable, the concentric rings were keep on coming out from that center. Okay, so with the each successive contraction, series of rings at different distances were actually coming out, and this process is being known as ring detachment. Here you can see in this particular that we have what? The rings which are actually coming out. It's because of the contraction in the middle or the core part of this particular. The contraction is more. Because of the more contraction, the centrifugal force is more. That's how the outermost part will have a affinity to move away from that nebula. That's how the centrifugal force used to work. I mean, you might have seen that if you are actually round, you have seen round on circle, especially circle, when we say meeting with the four roads, and if you circling this particular road which is circular in its path, you have to adjust your angle. This is because you have to balance out the centrifugal. Somehow if you slip over, so you will actually moving away from particular center. You might have seen, to rotate a one rope, and if you tie a one stone at the end of that rope, and if you circle that rope like this, and at one point of time if you free it, this will have a affinity to go away in this way. So this will going to go away in this way, means away from the center. So it's because of the centrifugal force, more centrifugal force. Why centrifugal force is getting more? It's because the density is getting more. Why density is getting more? Because of the self gravity of those dust particles. They keep on contracting, temperature is increased, density is increased, centrifugal force is getting more and more. As a result of this, concentric rings were actually coming out from that. While rings were detached, the central part of nebula kept condensing. This central part, now this is about the outer part, the central part was keep on condensing. So continuous contraction was there. Due to the continuous contraction, the central core which was there, its temperature was increased, and proto-Sun which was there, denser and hotter conditions were continuous. As a result of this, the sun was actually being emerged. So it's first the rings were actually coming out. This is the first development. Parallel to this, on the core part, on the center part, as the contraction is getting more and more, temperature is actually becoming more and more. The same condition of that Immanuel Kant. Now that the threshold is there, and as a result of threshold, the sun is actually formed. The sun is actually being emerged. The sun is actually being appeared. So here in this slide we discuss about the two contemporary developments. The first, due to the centrifugal force, the concentric rings were actually coming out. Due to the centrifugal force is increasing primarily because of the density. Now at the core part, as the density is increasing, temperature will increase. Due to the temperature, the core part of this nebula, this part will become more hotter. As it become more hotter, temperature will increase, temperature will reach beyond the threshold. As a result of threshold limit, what will happen? Proto-Sun was there, self-gravity of those dust particles, it started to what? Ignition, and as a result of ignition, the sun, the proto-sun, emerge or appear as a sun. So this is how Laplace theory, Laplace hypothesis